Okay.
Okay, let's continue, people. Let's continue. Go on, Engineer Isaac.
You in the mesh, please use 20 millimeter. Maybe when I use lower element size,
Yeah.
will be some distortion in the joint. So for this example, it's okay 20 millimeters. So every student, everyone's use in the element size 20 millimeters. Okay.
20 millimeters is very small.
Yep. Okay. And there is a questions, Karen, define the direction of the force. Okay. So you have to, okay, Karen, you have to, for example, for example, insert force. Okay. So when you insert force in geometry, you have to click, select a point. So in these three joints, okay, for the first force, you have to select this point, the second point, and then apply it in geometry. Then, in defined by in these options, select define by component, and then in the Y component, enter the value. But you see that the force is in the Y-axis, but in the negative is pointing downward. Okay, for that reason is minus this value. So if this value is equal, remember that the total load is 24 tons divided by 3, so is 8 tons, and 8 tons is equal to the 8,400 newtons. Karen?
Thank you, Ian.
Okay, also, you have to insert the other four, the same, similar to the in the middle of the point, in the middle of the structure, and then in the other points. Also, insert simple supports and select in the left end, and the other supports select in the right end. Okay, so you see that this is the boundary condition with these loads. So this is 3 loads and the boundary condition in the end. After that, you have to specify the solution that you want to see. So click on solution, right click, insert deformations, directional deformations. You have to insert 2 directional deformations. The first is in the x-axis, in the second one in the y-axis. Then you have to set up the actual force. For example, insert beam results and then actual force. See? And also for reactions. For reactions, using this path, insert, probe, for reactions. When you insert for reactions, you have to specify the support that you want to see the for reactions. In this case, simple support is in the left end. So finally, you see, for example, you see directional deformations in the x-axis. Okay. For example, these parts move to the right, and then this part move to the left. And you see, for example, using this, you see the maximum. Okay. You see the minimum. You can use this tool, probe. Probe is to see any value in any point, on any element. So you see, for example, in this point, you see in the other point, in this point. Okay. See, you see in that point, in the other point, and so on. The same for the y-axis. You see the maximum, the minimum. So in this point, it's 2.4 millimeters pointing downwards. So it makes sense because the load actual force. So you see the actual force by elements. Okay, you see this element is in compressions, this other element in compressions, this element is tensions, in compressions. So this is in compressions. Okay. So you can analyze this structure, and then for reactions. So you see the component, the four reactions. So you see that these four reactions have three components. Okay, in the x-axis, in the y-axis, in the z-axis by this is close to zero. Okay, and you can extract this information and then analyze the result and check convergence, prove other mesh. For example, in the element that is in compression, analyze if this element buckled or not. So this is the exercise. Okay, now your work is to do it, this exercise, but applied a uniform load. Okay, so let me ask you, and there are is there any questions? Is there any questions, students? For example, Zamora.
Good morning. No,
Okay.
it's fine.
Can you follow these explanations?
Yes,
Is easy or difficult?
I think it's also because I try to follow you and I did it, but it is a little bit difficult.
Okay, Carla Larrea.
Good morning, engineer.
Can you do it?
Yes, but I have an error in the solution. I don't, in this, I am looking, where is the error? I don't have the results.
Okay, in the mesh, use 20 millimeters.
Yeah, this put this value, but I don't have the results.
Why?
I don't know.
Oh,
Other
This-
student, okay.
let me say a couple of words. People, the first thing that you have to do is you have to read the message from the program. One more time, read the message from the program. Okay? Because the people who prepare this program, they try to help you. So try to understand what they mean and then try to go on and try to solve it. Go on, Isaac.
Okay, other students have the same problems?
Yes,
Or
I have
just
the
La
same
Pere?
problem.
Okay. If you want, after the class, you can show me this program, and then I help you. Okay. So now, now this is the example that you want to complete. So this is the same, but the I section B is different. Is 5 inches per 3 inches. So you have to look for the dimension of this I-beam in the web, and then to complete this exercise. So remember that in this case, the force is not applied in these 3 joints. It's uniform in the lower beams. Okay, so you have to do it, and then you have to calculate the maximum deflections and the maximum normal stresses in the bridge.
If we repeat with this new 5 times 3 beam, that's all the process we made of the loads and the super support erased.
Yeah, but the force is not in the total force is not applying in this 3 joint. It's in this line. This 24 towns in applying this part. So the simple support is the same. The I sections, the cross section is different. So you first you have to look for this dimension, this I beam in the web. Okay, look for the dimension, the properties, and then continue the exercise. Nevares. So in this case, the results, so you can set up the parameter of the deflections and the normal stresses, and see what is the maximum deflections and the maximum normal stress. Nevares?
Yes, I'm doing.
Okay.
Okay, people, what we can do is we can wait for some minutes. And then what we can do is we can ask somebody to share his or her work to all the class, okay? You do that, Engineer Isaac, okay? So
Okay.
let's wait for, say, 10 minutes, and then let's see if somebody is able to complete at least part of the exercise, okay?
Okay.
People, can you hear me?
Yes, doctor.
Is there anybody who was able to go on with example and you want to share your exercise with the rest of the class? Anybody? Anybody, people? If somebody wants to share, we can allow him or her to share the screen so we can all see what he or she has done so far. Even though it's not complete, but at least we would like to see some progress. Anybody, please? Anybody? Anybody?
I just made a mesh.
Okay, go on and Isaac, can you allow them to share the screen?
Okay, go on. Nevares, you can share now.
Well, by now I have the mesh.
Okay. What's the size of the mesh?
I put 1 inch.
Okay, that's, remember that if you have these very long
25.
elements, 10 meter long, probably if you use a 1 meter long element, that's enough. You don't need to use such a very small elements.
I can use bigger.
Yeah, 1 meter, that's enough. And remesh it.
Change,
It's 1 inch.
one meter. Nevares, change in unit.
Oh, no, leave it in inches, but how many inches do you have in 1 meter?
I have
People?
never asked the question before. It's right now.
Yeah,
Yeah.
that's it. Yeah, you see,
Okay.
the joints are very far apart now, but it's decent. That's adequate for this because it's a very large structure. When you use a very small size, right now you don't feel it because it's such a small example, but you have to worry about that when you get to your projects. Okay, anybody else who has done something, please, and can share with us? Anybody else?
I can show.
Okay, go on. Go on.
I don't know if this is correct.
Oh, no, that's fine. Where? Okay, so you have the load is okay in the first span. Okay, you have a line pressure. Good. Okay,
Yeah.
but you have to erase the other loads, right? Because right now, instead of the 3 concentrated forces, you have distributed force. Okay, so that's correct. Were you able to change the properties of the upper elements of the model of the bridge?
You mean the cross section?
Yes.
No, I did not know how to do it.
Okay, so you were able to change the forces. Instead of applying the 3 concentrated, you are applying distributed forces, right?
Yeah.
Okay, good. Anybody was able to complete the change of the section, people? Anybody?
Yes, doctor.
Okay,
I changed.
okay, can you share the screen, please?
Yes. This is my results.
No, don't worry, don't worry. There is no failure here. The thing is that there is a lot of, so the scale is very large. That's the only explanation. Don't worry. Okay.
I closed this modeler, and in the geometry, when I open the geometry, I can change the cross section, the
Okay.
dimensions. First, I have to change the metric units for the use units.
Okay.
Here. Yes.
Okay. Good.
Yes.
Okay. I'm glad. I'm glad. Okay, people. Before we break up, thank you, Mr. Peralta.
Thank you.
Before we break up, a couple of announcements. First, in 2 weeks, we will have the Naval Engineering Student Technical Sessions. Okay, we're going to organize a round table. So we want volunteers to participate in that activity. And the idea is that we have to be aware of the problem of inclusion. Okay, here we have women, here we have persons from outside our region. There are people from the Sierra, and even in the coast, we have different way of talking, things like that. So we have probably differences in beliefs, okay? But we are all people, we're all persons. So we have to accept each other. So in this respect, we want to organize this roundtable. And the idea is that in this roundtable, you will be given the opportunity to say your opinion, say 1 minute, okay, about something. For example, have you lived any experience, good or bad, in our university about this problem? Just 1 minute saying something about it. So everybody will be aware that these things are happening. That will be a question that everybody has to answer. 1 minute, that's all. Then, for example, something which is very important is, what can we do here at the university level in order to start moving in the correct direction? 1 minute. So I want you to tell us, okay, what do you think we can do? So everybody will be aware that these things are here. We have to face them, and we have to start thinking about how the attitude of each one of us has to change in order to move, in order to solve this problem. Okay, so I invite you to participate. If nobody presents as volunteers, then it's simply, you know me, randomly I have to select somebody and that's it. Okay, so that's that. It will be nice if we had men and women. It would be nice if we had somebody from Guayaquil and somebody from outside, so we can see the differences in opinions and things like that. Okay, so that's one thing. Another way that you can participate in the Naval Engineering Student Technical Sessions is through your presentation of your projects. Okay, this is a very nice experience, applying all of this knowledge that you have gained in these 3 courses: solid mechanics, ship structures, and finite elements, right? So yeah, I would like you to show again, you as a group will have to present this project during the week of exams. So this participation in the naval engineering student in the sessions is just volunteer. Okay, so I need 2 groups to volunteer to participate in the sessions. If there are no volunteers, again, I'm the one in charge. So I'm going to ask Engineer Isaac to select 2 groups to make them participate. Okay, so we need that. Any questions about this, what I just said? Any questions? Especially those of you who have not a very good English speaking skills. That will be a very good experience for you to practice. See, if you recognize that your English needs to be improved, this is a good way for you to force yourself to practice. See, don't take it in the other direction. See, try to take advantage of each one of these experiences in order to practice, and through practice, you can improve. See, we as a university, we have a big problem because in our standards, we said that every student from this university should reach the level B2 when they graduate from this university. Are you in that level? If you are not, then we have to make an effort in order to bring you up to the level that we say to the government that we're doing. So bear with me. I am not trying to punish you. I'm trying to give you the opportunity to improve. Okay? So if you don't feel comfortable speaking in English, the way it's the same for me. I prefer to do it in Spanish, but I have to do it in English. If you don't feel comfortable, this is a good opportunity. So talk to your teammates and present yourself as volunteer for these 2 activities. Okay, the Naval Engineering Student Technical Sessions, or the round, whether technical presentation or participation in a roundtable. I have to insist, this problem of inclusion is a real problem. It's a real problem. I was talking to my son. He works in a university in the US, in the upper part of the state of California. And he said to me that in his department, there was a female faculty who talked to him, and she said that when she went to talk to the dean, to the chairman of the department, she felt that the chairman basically did not listen to her. In first century, that's a first world country. But you can imagine that in our country, it's even worse. So we have to do something. So please present yourself as volunteers. We would like to see your opinion about this problem. Okay. So we can be aware the situations where these things are happening to prevent them. But we need to know it. Also, it's a good idea that you, as a student, tell us, what can we do as a community in order to try to include everybody in our community, not to let some people out. Everybody should be in, everybody should be included. Okay, now, before we break, see, I sent you last night or yesterday material for reading, for practicing for today's session. I would like to raise your hand those of you who were able to read that information and try to practice using ANSYS yesterday or last night? Please raise your hand. I would like to see how many. Okay. Okay. Many, not many. The thing is, those of you who did not do it, what can we do? Because we're going to do something similar for the next session. Okay, on Monday, we're going to go to the next example. And in that case, as somebody was asking, we're going to take this structure composed by plates. So we are considering, we're modeling this module of the whole as a composed by plates elements. So you remember in chapter 3, okay, we took a plate and we needed many more joints than in the first case, chapter 1 or 2. Of course, that means that when we do this in using ANSYS, you will see that the number of joints will increase. So the complexity of this exercise increases also. And remember that it's not only of getting some numbers. No, the thing is that after you get the number, I'm going to ask you, does that make sense? Did you converge? Does the structure fail? So we need you to practice. That's why we're taking this approach. Okay, so the number of students who review this material before the class is very low. So we need to increase. We want you to be aware that if you do this exercise before class, when you see it on Monday, Engineer Isaac explains, it will be much easier for you to follow the explanation. Much, much easier. Okay, so on when, Engineer Isaac, when are we going to give them? On Saturday?
What thing?
Saturday? We will send the material for the preparation of the session on Saturday,
Yeah,
right?
yeah,
Okay,
Saturday.
So on Saturday, I will send you the material. I will post the material in the Aula Virtual. So I would like to ask you to do an effort, take this material and try to follow, open your ANSYS and try to follow the explanation from Engineer Isaac. And then if you have questions, if you have any problems here and there, write them down. And at the beginning of the next session, we will start asking you, did you have any problem? And then Engineer Isaac will explain how to do it. And then you will practice during class. Okay, so be aware of that. Okay, and on Monday, we will do a progress control. So please be ready for that too, okay? So if there are no more questions, then if some students have problems with this exercise, okay, stay, or you, Isaac, maybe you can open a new session.
Yeah, I have
Okay.
our office hour now.
Okay, so Engineer Isaac have office hours right now. So if you have problems, please don't let it for tomorrow. Right now, come to Engineer Isaac's office hours and try to solve them. Right now, it's hot. You feel it, you have done it. Try to solve it right now. Because on Monday, the exercise will be a little bit more complicated. Have a nice weekend. Please remember that this problem of the COVID is really widespread. So everybody should cooperate. Remember, you and I are able to read, so we are more responsible. We are more responsible. One more time, we are more responsible. So try to cooperate. And if you are able to tell somebody else about an extra care, do it. Do it. Okay, bless. See you Monday.
Thanks, doctor.
Thanks, doctor.
See you, doctor. Have a good day.